Hi guys, in this video we are going to solve another interesting differential equation over here. If you haven't watched our previous video regarding solving the differential equation as well as any basic fundamental electrical or mechanical engineering videos, if you like to watch them, I have given the link in the description so you can always watch that. Also, if you are new to this expert tutor channel, please don't forget to subscribe it. Okay, without wasting of time, let's move to the question. So over here you can see that dy by dx, we need to solve this question. Dy by dx, which is equals to x squared plus y squared divided by x squared. So here how we are going to solve this part is we are going to use the type of to solve that homogeneous equation. So first of all, you need to know what's meant by the homogeneous differential equation. Let's say this is a function of x and y. This is function of x and y. If you put another non-zero element of lambda and multiply that by lambda x and lambda y, let's say this is function of x and y, so it's going to be similar to x squared plus y squared divided by x squared. So here I'm going to substitute that x by lambda x, but remember that lambda is a non-zero value and real value. So let's say the lambda is a real value, but it's not a non-zero element. So I'm going to multiply that by the x and y. Let's say here I'm going to substitute that lambda x and lambda y in the position of x and y. So if I substitute over here, I'm going to get, let's say I'm going to substitute over here relative to x is going to be lambda x whole thing squared. Likewise, if you substitute this lambda y over here, you are going to get lambda y whole thing squared divided by, likewise here it's going to be lambda x whole thing squared. So from that you can tell we have already decided that lambda is not equal to 0. From that, if you cut the lambda over here, lambda squared, actually you are going to get x squared plus y squared over x squared, which is similar to this function of x and y. So from that, what we can say is it's going to be, we are going to give a special name which is homogeneous equation. So that's the main part. So now we have found that this is a homogeneous equation. So how we can solve this part? So actually you need to know something. If it's like to relative to this part, actually you can use another simple thing or simple form. If it's a homogeneous equation, the y and x will have a relationship like this part, y is equals to v into x. Remember that v is another variable, so it's going to be like this. It's going to have a simple relationship between, there exists a relationship between y and x which is similar to y is equal to v and x. So if it's a homogeneous equation, you can directly use that. But when you are asked to find, or when you are asked to solve this equation, this kind of equation, you need to prove that this is a homogeneous equation by using these steps. You need to do that. After that only we have found that this is a homogeneous equation. If you want, you can write it over here, it's a homogeneous equation, so that we can directly use this substitution, y is equals to v into x. So after that, if I take like this, we can differentiate this part once. If I differentiate, I'm going to get the y prime, which is dy over dx. If you want, you can write it like this. Dy by dx would be, we need to take this v into one side and we need to differentiate x, dx over dx, which is 1, plus we need to take this x and differentiate this v, it's going to be dv over dx. Now we have found that. So after that, so this is the first equation. Now we have got one equation. The another equation we have already got from that question, dy by dx, which is equals to x squared plus y squared divided by x squared. So the idea is I'm going to change this dy by dx in the form of v and x, so that we need to substitute the vx to this y. So if you substitute that, we are going to get x squared plus vx whole thing squared divided by x squared. Let's take it like this, x not equal to 0. From that you can directly tell that dy by dx would be equals to 1 plus v squared over 1, which is 1 plus v squared. So actually we have got two equations for dy by dx, which simply shows we are getting the equation related to y, v and x. We are going to substitute that vx and going to get equations which is having two variables v and x. So let's equate this part. If I equate this, I'm going to get b plus x into dv over dx, which is equal to 1 plus b squared. So we are going to get to the final part. So how to solve this one? So actually you can use many methods. However, in this question I'm going to use the separable method to solve this. So actually we have already discussed about many questions in the previous videos using separable method, which is very simple. It's like another differential equation. When you are solving one equation, you are going to get another equation and you need to solve this part. So what's meant by the separable method is we need to divide the two variables in two opposite sides. So we need to bring that v to one side and x part in to another side, and after that we need to integrate that. That's very simple. So here I'm going to bring that v into that opposite side, so it's going to be 1 minus v plus v squared. So here you can see that x over dx into dv. So we need to bring this dv in that side, or either we need to put this part in over here in the left side, and after that we need to convert that into right side. So we can directly write it like this: 1 over x into dx, and if I bring this part over here, 1 over v squared minus v plus 1 sorry, into dv. So the final part is we need to integrate that. So let's write it like this. Let's write it like this. So the next part is how we are going to integrate this part. Actually we can write it like this. It's going to be v minus, sorry, it's not like this. This v minus half squared, like this. It's going to be v squared minus v and plus 1 by 4. So there is another part, root 3 by 2 whole thing squared is equals to 1 over x dx. So from this you can use the derivation of for this part, which is gonna be I think it's going to be in the tan inverse, right? So likewise you need to solve this part. It's going to be ln mod of x, and there's an arbitrary constant, so you need to put that also. After that you are going to get the answer. So I think you need to remember this part is going to, what's the value of this part. After that only you can solve that. Actually we are going to use the tan inverse or sine inverse, but I think it's going to be tan inverse. So please do that and comment the answer below so we can also check that. And there would be an arbitrary constant, so you need to solve that. Let's say after that you are going to get the answer in v. So you need to substitute this v using y over x, and you need to give the answer in y and x, because they have asked the question in x and y. So you need to change that to y and x before giving the answer. Okay, I think you can always try that. Please find the answer and comment it below, and if you like to watch our next videos, please subscribe our channel. Thank you for watching.